Hey, here we are. Woo! We're getting ready for our science show. Right here, we have a special guest, Mr. Burton. And Mr. Wall, that's Mr. Wall. And here we go.
All right, so everyone, as you're joining in with us, we're going to take a look at some liquid nitrogen because we haven't seen enough snow yet this year. So we thought we'd play around a little bit with the liquid nitrogen to show you a lot about how it can change the different properties and to do some cool experiments with it. So the liquid nitrogen, to let you know, we have it inside a Dewar flask that looks like this. This Dewar flask allows for us to keep the temperature of the liquid nitrogen super cold because nitrogen changes to a liquid at about negative 320 degrees Fahrenheit. So I'll say that again, negative 320 degrees Fahrenheit.
Negative 320
right.
degrees.
So when you think about it being cold at recess, just remember liquid nitrogen is a lot colder than that. All right, so as we look at liquid nitrogen, when it's in its liquid form, all right,
make sure you dress for the weather.
That's right, dressing for what? As we see it changing its states of matter, what we'll see is that as it pours out and as it changes from a liquid to a gas, we'll see it kind of bubble up. You can even see down on the ground, it's boiling over. And as it boils over, we see just for a brief moment this effect called the Leidenfrost Effect. And that's where, like, if ever you've cooked with mom and dad, like in a skillet, and you pour water on a really hot pan and you see those bubbles that kind of glide around, or later on when you see Mr. Ray on a hoverboard gliding around, it's a very similar effect, but that's because it's boiling when it touches the temperature as it hits room temperature. So what we're going to do is we're going to do a couple experiments with it. First thing we're going to do is we're going to change some states of matter. We're going to look at something such as flowers. As we anticipate Valentine's Day coming up, for all the times that you've given that flower to that special somebody, we're going to take a look at some flowers that, like right now, as you can see, and as we touch them, they're very soft. They have their very petal-like feel to them. They're very soft and gentle. Just because, again, you see as they're growing, you're not going to see it becoming brittle yet. They're very flexible. The state that they're currently in as a solid is a very malleable state. It's very flexible and very soft. But what's going to happen when we take them and we dip them into the liquid nitrogen is that it's going to change the way that they look and how they feel. So we're going to pour some liquid nitrogen into this bucket. As we do, we're going to dip some flowers then into the bucket. Go ahead, Mr. Wall. And what we begin to see then is that these flowers are going to change how they look and how they feel. So then as Mr. Wall goes ahead and pulls them out, and we let them cool and we continue to let them kind of adjust to that room temperature. Now, as we tap them on the surface, we see how that they're much more brittle. They fall apart almost like they're glass or that they're very fragile feeling. But that's because we changed the state of matter. We changed the state and we took it from being that really flexible to now we really froze them to where now they become very brittle. But as they warm back up, we'll be able to see them become that soft feel again as we look at the flowers. All right, another object that we're going to take a look at is we're going to look at now like this tennis ball or this racquetball. When we look at how it bounces, we can see that it's very bouncy. It has a lot of elasticity. What we're going to do with it is we're going to dip this into the liquid nitrogen. And as we do, we're going to see how it changes from being that very elastic, very bouncy, to now we're going to see how it reacts very differently. Because when you have something that's really cold, and then you bounce, or when you have something that's really cold that's normally really elastic, its elasticity goes away. And so then what used to bounce really easy is no longer such a bouncy object. So we're going to go ahead and pull this out. And then we're going to drop this and let it see how well it bounces now. Ooh, not nearly as well as what it used to, because we've changed its elasticity. This is like when you think about a rubber band that gets really cold and then you try to pull it apart and then it breaks. The same thing can happen. So as we use that racquetball now, as it warms back up, we'll be able to see it bounce a lot better. It'll have that elasticity again. But right now, it's now kind of that frozen feel to it. Another thing that we're going to take a look at, I'm going to grab over here a banana. And this banana, if you think about like how you would go about hammering a nail into a block of wood, a banana is probably not the tool you're thinking of. You're thinking of what Mr. Wall has. You would normally use a hammer. But if you don't have a hammer, but you do have liquid nitrogen, because how often does that happen? You could actually use a banana to act like a hammer. So what we're going to do is we're going to dip this banana into the liquid nitrogen. And I'm going to use a glove because, again, I want to make sure that I protect myself as I do this. But I'm going to pour a little bit more liquid nitrogen into the bucket or into the bowl to be able to get me enough that we can put the banana in and submerge it. All right. So now we're going to go ahead and dip this banana in and let it completely coat. We're going to freeze this banana so that it can become like my hammer. And then once I have it frozen in the state to where I can use it like a hammer, I can then show you how we can knock this nail into the wood. But again, what we're doing by putting it into liquid nitrogen is we're doing a quick freeze. We're freezing the object at temperatures that, again, that are much lower than normal, much quicker freeze than what you would do if you put it in in your freezer at home, because we're talking about temperatures at negative 320 degrees Fahrenheit. So as we put it in here, it's freezing that banana to where now I can use this banana almost like a hammer. All right. Oh, I got a little too soft. There we go. All right, let me freeze it a little bit better. I didn't freeze it long enough. Let me keep freezing it. As you saw, I got it too early, so it started to actually get through. But you could hear a little bit of how it was nailing and how it was getting it into the block of wood. But again, that's because we are submersing it in that liquid nitrogen that's freezing it and changing how soft it is at room temperature to then making it a solid that we can use it a little differently than what you would typically use a banana for. Because you wouldn't normally use it like a hammer. But let's see. All right, so I didn't get it all the way in, but you can see it's starting to knock into the wood. But again, this banana changing its state of matter, or is changing, not its state of matter, changing its physical properties as we're making it much colder. All right, so the next thing we're going to do is I want to show you how liquid nitrogen can also change temperature. So when you think about this ball and hoop that we have right now, this ball and hoop, how you would use or what you could do is putting the ball right through the hoop. It fits easy through, almost like a slam dunk. But what happens when you submerge the hoop part into the cold liquid nitrogen is that it contracts. It's almost like when you think about things that get cold that begin to expand or when they begin to contract, when you change their temperature so rapidly, what you begin to see is now the things don't work the same as they used to. Now I can't get the ball through the hoop. There we go. Let's see if I freeze it up a little bit more. But as I try to put the ball through the hoop again, it's not the same as what it was when it was much warmer, because I've now, by submerged or putting it inside the liquid nitrogen, it's much colder and it contracts and it makes it so that it doesn't go through the hoop as easily. So now it's not that easy fit. But as it warms up and as it begins to expand, the ball will be able to go back through the hoop easy without it kind of getting locked up as we see here. All right. So another thing we wanted to show then is now how we can look at our breath when we use a balloon. So I'm going to go ahead and use my breath to go ahead and blow up. All right, so as I blew my breath into the balloon, what we're going to do is we're going to go ahead and condense the air. So right now, air, if you think about the three states of matter, you got a solid, liquid, gas. Air takes up the most volume. So right now, the air from my lungs is now inside the balloon, and right now it fills up the balloon. So what happens when I begin, though, to put it into the liquid nitrogen is it changes that air into a liquid. And what begins to happen is now my balloon will begin to condense get smaller and smaller as I'm freezing or I'm changing the state of the oxygen and the carbon dioxide in the balloon to a liquid. And it's getting smaller as it's continuing to freeze. So it's changing that gas into a liquid. So now when I pull it out, you can kind of hear that liquid air. And as it begins to heat up, you're going to see the balloon begin to expand because now it's changing again from that liquid back to a gas. And when you look at states of matter, that liquid to a gas is much larger in volume. So this is why it will expand the balloon. And when it was a liquid, it was much smaller because it wasn't filling up as much space. But that's, again, just changing my breath into a liquid. All right. So the next thing we wanted to do is to cook an egg. So cooking an egg using a frying pan, and this is not a boiled egg. This is a raw egg. So we're going to go ahead and crack the egg and put it inside the pan, just as it is. And what we're going to do is we're going to cook it. We're going to change its physical state using liquid nitrogen. So here we go. So as we are cooking the egg, we're freezing the egg, we're changing its physical state. Normally when you cook an egg, you think about how that you're doing a chemical change. That chemical change is making the egg change that you can never undo those chemical changes. It changes its proteins and its properties that then it becomes something that's then permanently different. You can often tell when a chemical change happens because there's a smell that's given off or it changes its color, all right? But when we look at this physical change right now, what we have is the egg is being cooked or frozen, if you will, by the liquid nitrogen. So as I pour out what I have left over, now we got a cooked egg. Now, here's the thing, boys and girls, this is not actually cooked, so you wouldn't want to eat this. This is just freezing at such a quick temperature that it's changing its physical state. And then over time, as this begins to warm up, it'll then become that runny and that soft egg again, that you would actually have to cook if you want to actually eat it. But what we have, again, just that egg that is frozen to my pan that, again, it looks cooked, but that's only because of the physical change that happened with the liquid nitrogen cooling it at such a fast speed. All right, so the last thing Mr. Wall's going to help me with this, we're going to make some dragon's breath. So to do that, we're going to use some marshmallows. We're going to dip them in liquid nitrogen. So we'll dip a few in liquid nitrogen. We'll get off those flower petals. You don't want to eat those. Dip these in liquid nitrogen. And then as we do, they're going to cool very quickly. And then we're going to be able to put them out on the table, let them sit for just a brief moment. And then once they've cooled or warmed up a little bit better for us, we're going to then go ahead and show you how we can have some dragon's breath. All right, you ready, Mr. Wall?
Oh, absolutely. Let's try. Is this okay for me?
That's right. So we're going to pop it in. And I don't know if you guys can see that very well. Let's try again. You see that, Mr. Ray?
You know what? Yes. Just real quick.
You want to try it? Let's get you some, Mr. Ray.
Well, here's the thing: is this is a soft one. I can smoosh it. This one I can't. Hard as a rock.
Sounds like a piece of chalk. All right, so as we looked at different things with the liquid nitrogen, some of the different experiments, boys and girls, these are ways that we can change physical properties of different objects and be able to see how liquid nitrogen at its extreme negative temperatures can help us be able to experiment with how we can change things and make things different by using everyday objects and changing how they look and how they feel. So, and turn it over to Mr. Wall and let him share with you what we're going to be doing next.
All right, boys and girls, come on, take a walk over with me, and let's go to our band. Now, this is no ordinary band, boys and girls.
Oh, no.
This is a very special band. This is called a makey band. And what we have here are 3 computers. And instead of a regular piano, we've got some fruit today. We're going to be playing our band with bananas, with oranges, and with water, if you can believe that. We're going to play Jingle Bells for you. But I've also got a very special gas here inside these balloons. Anybody know what it is? It makes balloons float. It is helium. So helium does some funny things to your voice, as well as making things float. Because it's a very light gas, it's going to make your voice change a little bit. So who all wants to hear Mr. Ray's voice get really, really high? So we're going to fill up a couple of balloons with helium here. And when we do that, it's going to be a very light gas, and it's going to make these balloons want to fly away and float. But if we take that gas and we take it in, here's one for Mr. Burden. I'm going to get one ready for Mr. Ray. Here's a balloon for Mr. Ray. And I'm going to get a balloon for myself. We're going to try to play and sing Jingle Bells for you guys here today. I don't know if we can do it, but we're going to play it not with pianos, but with bananas, oranges, and water. So we're going to try to play this tune with the instruments we have here today, but we're going to try to sing it. So first of all, Mr. Ray, I want you to suck in that balloon, and we want to hear how you sound. We're going to tell them the Washington way with helium.
Okay, it's the Washington way!
All right, boys and girls. All right, I'm going to say dress for the weather.
Dress for the weather! All right, Mr. Burden, he's up next. Let's keep reading!
Reading! Let's all do that together because that's fantastic.
Let's keep reading! Reading!
All right, boys and girls, don't try any of this at home. Try it at a friend's house. Always, every time. All right, boys and girls. Woo! I need to catch my breath. We're going to sing Jingle Bells to
Jingle
you
bells.
with pianos, oranges, and water. So we have right here we have our earth key. That's going to let me play some notes on here. So let me get it all tuned up. There's my orange piano. Would you tune up your piano, Mr. Vernon? Beautiful bananas.
Wait a minute. He's got me hooked up in water. Electricity and water.
Well, Mr. Ray,
I'm thinking I'm going to have a shocking good time today.
let's find out what happened. So stick your finger in that one, and then stick your finger. What was that, boys and girls? All right, we're going to try to do the tune of Jingle Bells for you. Here we go. A 3, a 2, a 1. 3, 3, 3, 3, 3, 3, 3, 4, 1, 2, 3, 4, 4, 2, 2, 3, 2. Oh, that's a wrap, boys and girls. Way to go, Mr. Ray. Way to go, Mr. Burden.
Encore, Mr. Ray. Second verse.
I'm trying to make Mr. Bullock proud of me. Because he says I couldn't carry a tune if I put it on my back.
All right. Hey, boys and girls, we're off to our next place here. This one's going to be a fun one for you guys to follow along with. We're going to see who can win this race. So follow me and I'll walk you through how this race is going to work. So right here, first of all, what the person has to do is blow off all this toilet paper. But they have to use a leaf blower. Mr. Ray, of course, gets the biggest, most powerful one. And Mr. Vernon, he gets the medium-sized one. And I'm going to get the cutie one right here, all right? So after blowing off all the toilet paper, this is Mr. Ray's favorite, by the way, walk across eggs. Mr. Ray's barefoot right now. He's done this before. He's broken every single one. We'll find out what happens. Moving on, you have to knock the egg into the cup. But you can't touch the pie pan, and you can't touch the tube. Lastly, we're going to have our Christmas trees. Mrs. Guilford, Mr. Heinzman, and Mrs. O'Malley down here. You trapped as Christmas trees. First one to finish takes off. All right, guys and gentlemen, get ready. Give your engines a test run. Two, one. Mr. Ray is already walking on his legs.
You're supposed to jump on them.
Spread your weight out. Spread your weight out. Oh, now get ready to go.
Oh, yeah! So crazy!
Oh, man. Oh, I found one crack. Oh!
I got
You won?
it?
Oh! That's nasty.
There it is. All right.
Oh! All right. Here we go. We got to make our tree.
Why do you have the shortest tree?
Sure. Yeah. There we go. There we go. Hey, this is going to be a good tree. Okay. There we go. Oh, man.
All the way around.
You're going to use that whole thing, Mr. Bernard. The whole thing? All right, that's it. Get your phones.
You didn't use the whole
I
thing.
didn't That's a lot. I'm getting dizzy.
We're making rules.
Hey, they vote. They're going to vote on the best tree, so.
Oh, that's free.
That's true.
There's the vote. Ah.
All right. My tree at least has a scanner. That's
Hey,
already
that's cheating.
festive.
That's cheating.
Oh, it stayed.
Okay.
All right, one more.
There. No, I can't. We'll just do it twice on top. There we go.
Ah!
All right. Hey, boys and girls, which is the best tree? All right. So, who won the race? I don't know. Mr. Ray didn't break any. What do you think? Vote if you think Mr. Ray won. Vote for Mr. Ray. Let's hear you. All right. If you think Mr. Burden won, let's hear you. And if you think Mr. Wall won, let's hear you. Yeah! All right, guys. Well, everybody's a winner on today. Let's go on. Let's give these trees a big round of applause. All right, guys. Come follow me. Let's move on.
Let's go.
All right, guys. Now for this one, we're going to play a little trick on Mr. Ray. Don't tell him. Don't tell him, all right? So,
What do you mean you need me in the office?
all right. So we've got 3 cups here. 3 ordinary cups. We've also got a cup of water. I'm going to pour the water into one of these cups. Okay, which one has the water? All right. I'm going to move them around a little bit. Keep your eye on the one with the water. Mr. Burden, which one do you think has the water in it? Did you keep your eye on it? Which one do you think has the water in it?
To be honest with you, I really wasn't watching at all. So,
Take a guess, Mr.
yes,
Burden.
I'm gonna guess that this one has the water.
All right. All right, Mr. Ray, come over here, please. Mr. Burden says this one has the water in it. If it's in here, Mr. Ray is going to get very wet today. 3, 2, 1. Oh, safe. It wasn't that one. All right. Mr. Burden, which one do you think it's in?
It's got to be that one.
All right, let's try. If it's in this one, he gets wet today. Oh, he's safe. It's got to be in this one. Mr. Ray, if the water's in here, you're about to get a bath. But we're going to find out. Count down with me. 3, 2, 1. What? Where did the water go? You were watching the whole time. Where did the water go? It's magic, boys and girls. I'm dry. Mr. Ray's dry. All right, boys and girls, follow me. Follow along.
Where'd the water go?
Magicians don't give away their secrets. All right, guys. For this one, we all have a minute to win it. Mr. Burden, Mr. Ray, and I are going to try to launch as many rockets as possible. And we're going to tell you the science behind this. Mr. Burden, would you tell them what the science is behind an Alka-Seltzer rocket?
So we're looking at, similar to when we were talking about the liquid nitrogen, a chemical change is happening. So a chemical change that's happening between the water and the Alka-Seltzer tablet. So it's going to be changing from the solid that it is as it goes into the liquid, and it releases a gas that's going to then change, and going back to its volume, because when a gas has larger volume than a liquid and a solid, it's going to expand, and as it expands, you're going to see something pretty cool happen.
All right, so what we have in front of you here is some Alka-Seltzer tablets. I dropped a couple in the water so you could see all that gas coming out. Now, we also have these old school film canisters. Back in the day, people, when they wanted to take a picture, they couldn't just use their iPad.
What do you mean back in the day? My day!
When people wanted to take pictures, they had to keep the film dark or it would expose it. So these are actually film canisters, but we don't use them anymore, only for Mr. Ray. All right, guys, so we're going to break up some of these tablets. We're going to put some water in our canisters, okay? So I'm going to do one here, put a little bit of water in there. I'm going to find a cap. I'm going to put the cap on, nice and tight. I'm going to flip it over. We're going to let that sit. We're going to have 1 minute to see. Oh, that one popped. We're going to have 1 minute to see how many of these we can do. We each have our own water. We each have our own tablets. Hey, no fair. They've already got some canisters and lids. All right. Let's go, gentlemen. 1 minute, however many you can get in.
Minute to
Minute
win
to
it.
win it.
Minute to win it. Here we go.
All right. Cap them. Flip them. Cap them. Flip them. Put an Alka-Seltzer in. What?
Oh.
1. I'm at 1. All right. Whoa!
Hey!
All right, Mr.
That
Burns
was
got the
mine.
highest. All right, he's at 4. I'm at 3. Mr. Ray's at 0.
Come on, Mr. Ray.
Yeah.
All right, I'm at 4. I'm at 5. Mr. Burden's at 6.
I think you're
Mr.
being
Ray's at
generous
0.
with your
I'm
counting.
not doing too well here.
All
I
right.
think somebody's read this.
Oh! All right. Oh!
I think it's rigged.
All right, got to find a cap. Mr. Burden's at 7. I'm at 6. Mr. Ray's at 0. Are you at 0, Mr. Ray? Or
I'm
you...
at 0 because I think somebody read that.
Oh, not a lot of Alka-Seltzer. All right, we got 30 more seconds, I think, maybe less. I haven't been keeping track.
Oh.
But Mr. Burden is clearly in the lead.
That wasn't a very exciting pop on that one.
All right.
Oh,
Oh!
I got him. I got him on that one.
Oh!
There's 2. Everybody. I got 3.
I didn't know this was
All right.
gotta give a warning.
Christmas story.
Warning.
There's that one,
Where's
right?
my
Oh,
safety
we're gonna go
glasses?
back.
Oh, all right.
Let's see. We may need a new light after that one.
There it is. All right, well, boys and girls, I think we have a clear winner here, right? What do you think, Mr. Ray?
Ah!
They're still going off. They're still going off. All right, well, Mr. Ray had a slow start, but he was a comeback kid there, and I think he took that challenge. All right, guys, we are going to head outside to show you another demonstration, all right? We have 3 rounds.
Huh?
Mr. Ray's going to do one. Mr. Burden's going to do one, and I'm going to do one. We have to put our shoes back on, so Mr. Ray's not even wearing any socks. So take a minute. We'll be right back after these messages.
Let's look at the table.
All right, boys and girls. If you'll follow me,
This way.
I will show you a little bit before we head outside what we're up to. So, first of all, we have this giant flask. This flask is 5,000 milliliters. 5,000. This is a big flask. We also have some hydrogen peroxide, kind of stuff that your mom and dad put on your cut to help clean it out. It was a really good job cleaning. Then we've got some soap and a little bit of potassium iodide. This is a special chemical. It's going to help react with the hydrogen peroxide. So we're going to see a little bit of an explosion here today, or more of a fountain. All right? So we're going to go outside to do this. We need to be outside so we don't get it all over and mess in here. So, Mr. Ray, would you mind carrying that one?
Yep.
Are you going to
Mr.
watch?
Burden,
Okay,
you carry
thank you.
this one. So in there is just water and our potassium iodide. And you do that one. And I got this one. And Mr. Ray or Mr. Heinzman, would you be able to get that one? All right, we got our food coloring and our soap. Yep, so we need our soap.
Here, I got another hand.
Let me do that.
You got a hand.
All right, you got that? Yep. All right, we got our hands full, boys and girls. I promise you won't want to miss this one, so we'll be heading outside here to get set up. If you'll follow us out into the grass.
All right. I have the boom mic.
So make sure we pick it up.
Yeah.
Oh, goodness.
That is a mighty large flask.
Ah, yeah. And I got nailed a few times.
All right, out we go. Right here.
Exactly.
All right, well, these kids can see it, I guess.
Hey, you guys got to figure out the concept of backlighting.
Yeah.
We should go over there.
Hey,
Where?
we are live, so you're making critical. Listen to him. Listen to him.
Face this direction.
All right, guys. Well, so the first step is we're going to pour in our hydrogen peroxide. We've got 500 milliliters here, okay? We're going to go ahead and pour this in. Now, the next step is Mr. Burton's going to pour in dish soap. All right, just your ordinary, everyday dish soap here.
Can you see it?
How much you want me to put in?
Let's
Yes.
do a generous squirt. That's good. Now mix it up a little bit. All right, very good. Now, we want this to look like a candy cane when it comes out because it's festive, it's Christmas. So, Mr. Ray, Mr. Burden's going to do some green and red stripes for candy cane down the sides. So we're going to do some squirts down the side, all around. Oh, there you go. Nice. Do a lot. We need a lot. Yeah, we're going to get some nice stripes here today. All right, now we're going to put some red in there because we want that. Well, this will be very festive, red and green for Christmas colors. All right, guys? So we've got these draining down the side. We've got some good colors going on. Now let's have Mr. Ray be the first one to actually put the chemical in that's going to make this go. So Mr. Ray, when you pour that in, it's going to start a chemical reaction. It's going to shoot up.
Oh, what? What? Wait,
in
wait.
the air.
Yep. Yep.
So you can shoot that.
Worried about
Wait,
that.
wait.
Shoot that a little bit.
Give me a countdown of 3.
When you say shoot up in the air, what do you mean?
Yeah, am I? Oh, gosh.
Oh,
have mercy.
nice.
Woo! Look at that. That is foamy. That's what we're talking about.
Nice.
Still going. Still going. Still going. Still going.
That is elephant's toothpaste.
I can't see it.
Elephants like to brush their teeth with that. So you're going to notice that it's giving off a lot of heat. This is a heat reaction. It's an exothermic reaction, so it's going to give off a lot of heat. You can see it steaming. It's very, very hot. That hydrogen peroxide, when it mixes, gives off a lot of heat in the process. All right, guys. I think we got another round in this. I think Mr. Burden needs to be able to launch one off himself as well.
Oh, goodness.
So
What do you
still
think, Mr.
going.
Burden? I'm doing as I'm told.
All right. I'm gonna go rinse this off. I'll be right back.
Meanwhile, Mr. Ray's going to do a little song and dance for us.
All right, since we didn't dress for the weather out there.
We need a word from our sponsors.
Don't do
Those
this
who
at
are
home.
Behind the scenes, we can turn the camera
No.
back so that everyone can see who's working behind the scenes.
We're good.
All right, Mr. Burden, you and I are both gonna dump ours in. We'll try. We'll find out what happens. We're gonna test a little experiment here.
If
What
one,
happens if we dump
what happens with
2? So,
Huh?
both of these potassium
Uh-huh.
iodide. This time.
Because, hey,
In
if
other
one
words,
gives
stand
up,
back even a little further.
Yeah. Okay.
two's got to be even bigger, right?
Always go bigger.
Always go big. Go big, go
Can
home.
you get that off? My hands are all slimy, Miss Burden. I don't have your strength. Thank you. Go do the honors there. So we're pouring in another thing of hydrogen peroxide.
Need more?
We need one more.
All I see is you, Mr. Heinzman.
Me?
The glare.
Oh, okay.
I can't see.
Okay, here we go.
I'm really hoping it's...
All right. Oh, that's good.
Yeah, just
Oh,
keep
well,
going.
okay, put it.
Just keep going.
Go ahead. All right, we're gonna do another good squirt, a generous squirt of dish soap.
Mr. Ray, why are you holding back?
Oh, no.
All right,
It's
we've
just
got
glass.
our food coloring, right? Let's make it festive. All right. We do the green first. Do a nice generous squirt down the side. That was really nice festive Christmas colors. Let's do it again. All right. We do a candy stripe here. Let's do a little bit more, get more color in there. More color is better. All right, guys. Mr. Burden and I are going to do this at the same time.
Go.
3.
Oh, nice.
Oh! Where'd it go?
It disappeared.
That is a lot of foam, boys and girls.
That's awesome.
Boys and girls, that was awesome. It's even making bubbles. Look at all that steam. Look at that foam. That is a lot of foam.
Toothpaste. All right.
All right.
How we doing?
All right, guys. So we're going to take it back inside. We're going to finish up with you guys today. End this with our hoverboard ride with Mr. Ray.
Here
We're
we
going to
go.
test out Mr. Green's leaf blower. The big
All
one.
right. Here we go. Down the halls.
Those are your boots, aren't they?
Here we go. In the hallway.
All right, Mr. Ray. How are your driving skills?
Well, we're gonna find out. We added some extra mechanisms to help guide this. Let's see if it works.
Rise up and go down, kind of like that liquid nitrogen we were talking about. But we had an idea. We said, would Mr. Ray steer us if he had a big old leaf blower? Mr. Green had one. He was so generous as to let us borrow it.
Like an old one. You gonna go down the ramp? Oh, down the ramp. Oh, yeah.
Oh no, he's coming back.